Hello, everybody. It's my pleasure to be part of this Canola Week. I'm going to talk about the quality of the 2021 harvest. And I will, at the end of the presentation, show a couple of slides on the quality of the 2019 overwinter canola. This year was characterized by lack of moisture, deficit in moisture starting early in the season and going through to the entire growing season. This is the maps in June and July, but the map in August will be very, very similar. We had a couple of rains in September, late August, early September, just at the time of harvest that led to a bit of spotting in the canola seed. The second part of the growing season, or the second theme of the growing season, was the high temperature during the day and high temperature at night. And that was a lot of a problem because the crop didn't have time to recover during the night from the heat of the day. Those two maps showed the number of day over 30. And day over 30 is quite important in canola because a lot of studies show that actually the threshold temperature for canola is 29.5. So yield is going to be affected when you have such a high number of days with over 30 degrees Celsius. There is also quite a bit of paper showing that if you add high temperature before flowering, you're going to affect the oil content. And if you have a high temperature after flowering, you're going to affect the fatty acid composition. So oil content and fatty acid composition are going to be greatly affected this year, just looking at those maps. So we had quite a bit of sample. When I ran the statistic analysis on November 18, actually, we had 2,000 sample in the harvest. And if you compare to last year, it's very similar and even way more than the year before. 2029 actually, when we had the bad weather in September and October and the snow stopping the harvest, and same thing in 2018 where actually we had snow for Thanksgiving in Manitoba, and that stopped the harvest for a couple of days. So for the number of sample, we had quite a fair number of sample this year, showing that harvest actually were proceeding well and not too much of an issue. When we look at the sample that we receive, and that map actually showed the lack of sample compared to last year. So the darker the color, actually, the more sample we get and the less deficit in sample compared to last year. And that might be actually giving us an idea about how the harvest, the amount of harvest and how the harvest was done, because if we're missing sample in some area, it's probably because there was no harvest in this area, or a lot less than the last year or the year before. So crop District 7 from Alberta, 4, 2, and 3, actually, we missing about 30 to 20 and even 40% of the sample in some area, whereas actually the 9B from Saskatchewan, we even had more sample than last year. So that's quite a bit maybe of a representation and how the yield and how the growing condition will affect the harvest of the crop. So all the historic data, I went back to 2000 because actually 2000 was, in 2003, we had a hot and dry season. And it was really interesting this year to be able to compare the result of this year from the result of last year. So all the data will go back to 2000. So if we look at the grade distribution, actually, we had a great number of sample that were grade number 1, meaning that even if you had hot and dry condition, the grade of the sample was not affected. And if you look actually at 2003, we had 89% of the sample that were also graded number 1, meaning that, even if you have hot and dry condition, your grade is going to be good. Actually, if you look at the data, like 2017 and 2018, we had 74% of the sample that were graded number 1. So what is actually affecting the grade of the seed is not so much the heat and the heat stress as the frost, the early frost in September, or the snow in November had we that, as we had in 2018 and 2019. So hot and dry condition, not so much affecting the grade. Cool condition, frost, early frost in September, will the one affecting the number of grades. So this year, quite a big number of number one. So if we look at the grade distribution, actually, this is another slide showing actually the heat was not so much, is not so much a parameter affecting the grade. The crop district 7 from Alberta with the Peace River is the area where we have the lowest number of number one, between 70 and 75%, where actually the south part of Saskatchewan here, which is normally hot and dry, that's where we had over 95% of the sample and 1% of the sample that were graded number one. So quite a bit, quite a fair number of samples that were pretty good actually from those hot and dry area. So what was affected actually by the hot and dry was the oil content. Oil content was low, 42%. Over 2% lower than last year, and over 2% lower than the 5-year or even 10-year average. Some of the sample were very low, 33% in oil content. It's quite low. We haven't seen that in a very long time, but that's a result of the growing condition. Something that's quite interesting if we compare to last year, for example, is to look at the average in Alberta. There is not much difference in 2021 between the three provinces for average, where last year actually there was quite a bit of difference between Alberta and the other two provinces. And because actually the north part of the Alberta is always cooler than the rest of the prairies, and because of that you have higher oil content in this area, where actually this year the entire growing area for canola was submitted to same hot and dry condition, and that's what we have here. We have exactly the same oil content in the three provinces. So if we look at the oil content historically, this is the second lowest oil content in 20 years. 2023 was the lowest hot and dry condition again. This one actually was open pollinated canola mostly in our harvest, whereas this year actually we had mostly hybrid, and that's the main difference between the two, but similar oil content. Now, when we have low oil content, we have higher protein content, and that's what we have here. We have about 3% higher in protein compared to last year, and 3% higher in protein compared to the 5 or 10-year average. Meaning that the meal this year will be very good quality, and actually the meal will be, for the protein content, will be as good as the soybean meal. And when we see here, actually, this is really an effect of the environment. When we have this highest protein content, this is the highest protein content that we have in 20 years. So, glucosinolate. Glucosinolate is slightly higher than last year, about 2 micromole higher than last year. There is a couple of papers coming from Alberta, from Australia actually, that show that when you have hot and dry condition after flowering, you will end up with a higher glucosinolate in the canola seed. And that's what it is this year. Actually, there is a slight effect on the environment pushing the glucosinolate high because we had hot and dry condition, but 10 to 12 or 11 micromole per gram is still a very good and very low glucosinolate content, and it's not going to impact the glucosinolate and the quality of the meal. So that won't be an issue, even if you see over the factor on the environment. And this is what we see here when we look at the historic data. Actually, you have a jump in the glucosinolate due to the weather condition. So chlorophyll. Chlorophyll, it's the lowest chlorophyll that we have. This is the 10 milligram per kilogram. It's the lowest one we had ever, at least in the last 20 years. We were kind of worried at the beginning because usually when you have hot and dry condition at the time of harvest after swatting, the chlorophyllase is not working so well in the seed, and you end up with a lot more chlorophyll. But that was not the case this year. So very low chlorophyll content in the crop. We didn't see the big range of the big swing that we have in chlorophyll usually. Sometime even in the #1 Canada, you can end up with a 40 or 50 ppm of chlorophyll, and that was not the case this year. So quite low chlorophyll content. Alpha-linolenic acid, very similar to last year, 8.8 to 8.9%. We also had quite a bit of hot and dry condition at the end of the season last year that was pushing the alpha-linolenic acid a bit lower. So that's what we see this year. Also quite interesting to see, again, same thing as when we were talking about the oil content. The important difference between this year and last year for the Alberta average. Again, the entire Alberta province was under the same hot and dry condition, and the north was not spared like it was previously, and that's the reason why actually you have alpha-linolenic content very similar in the three provinces. So if you look at the historic data of alpha-linolenic acid, this year is quite similar to last year, but what you see actually, you have a decrease over the year on the alpha-linolenic content for the seed, and that's kind of more of a genetic effect, whereas this year compared to last year, or this one compared to this one, it's an environmental effect. When we look at the glucosinolate, when we look at the alpha-linolenic acid, we also look at the oleic acid, and one going lower, the other one getting higher. So we have higher alpha-linolenic acid, slightly higher than last year, but not really statistically higher. But important to see again in Alberta was the difference of the average of last year compared to this year. Again, confirming that, weather was the same over the entire canola growing area. No differences. And this is the historic data for oleic acid. And the same way that we saw alpha-linolenic acid going down over the last 20 years, we see oleic acid going up over the last 20 years. Iodine value, because alpha-linolenic acid and oleic acid were similar to last year, iodine value is similar to last year, so not really important differences. And again, notice the decrease in iodine value over the last 20 years. This year it's much lower than the 5-year or 10-year average. So this slide is kind of a resume of the quality of the crop, quality of the 2021 crop. Oil content is extremely low, one of the lowest that we have almost in 20 years. The protein content is the highest that we have in 20 years. And chlorophyll content is actually the lowest that we have in forever in all the grades. Usually when you have #2, #3, you have, like 50, 60 ppm of chlorophyll. That's not the case this year. So chlorophyll, it's really, really low. And that's just a result of the growing condition. So now a couple of works, going back in time, going back in 2019 or 2020 when we did the analysis. 2019, we had, like 20% of the crop in Alberta that was not harvested, and 10% in Manitoba and Saskatchewan. So, and that crop was harvested in the spring of 2020, and that's when we ran our project. So the important parameter that we look at the beginning was the main quality parameter and oil content, protein, and glucosinolate and chlorophyll. And we'll look at actually the oil content. And when we compare the oil content from the fall over the overwinter sample, we have a higher oil content in the overwinter sample compared to the fall sample, even if it's not really statistically different. This is not due to the overwintering of the crop. This is due for the geographical location of the sample. The 29 samples that we have that were graded number 1 were actually coming mostly from the north of Alberta. And by tradition, the north of Alberta are usually higher in oil content than the rest of the provinces and the rest of the growing area. So that's looks like overwinter is producing higher oil. That's not the case. It's just geographical differences. So the other parameter that you have to look at when you look at overwinter canola is free fatty acid. And so that's what we did. So the fall sample, actually, it's the fall composite that we do in January, and then January and December, and then we analyze them right away in December. We analyze the parameter by wet chemistry in December, and we're comparing those data to the overwinter sample. And we did the overwinter sample. As soon as the sample got into the lab, we analyzed the sample to get the quality. And then we analyzed them about 2 months later, and that's our storage. So much higher free fatty acid content in the overwinter sample compared to the fall sample, about a bit more than twice the amount. And that showed that actually overwintering is producing higher free fatty acid in the sample, which is normal when you think about it, because those samples are being under the snow and high moisture condition for a couple of months. So that's the result of the overwintering in high humidity. We did the analysis about 2 months later, because in 2019 we saw that there was an increase in the free fatty acid. So we did the analysis in the overwinter canola 2 months later, and for the fall sample we analyzed them in August and September, so about 8 to 9 months later compared to the first data. And we saw an increase in both free fatty acid for both samples, for both type of samples after storage, about 0.15% for both samples, except that for the overwinter canola, that increase was over 2 months, where for the fall sample, that 0.15% increase was over 8 to 9 months. So the free fatty acid in the overwinter canola increased much faster than in the fall sample. That's one of the things. Another problem was actually with the overwinter canola is, if you see, there is quite a bit of a range in the free fatty acid content. Some of them were really low. They were as good as the fall sample, and some of them for the number 1 were really high. And that's kind of one of the issue of the overwinter canola, because when you do the analysis, you have to do the wet chemistry. There is no rapid analysis telling you the sample is going to be low or the sample is going to be high. So at the level of the crushing plant, you know that you're going to have a problem with the free fatty acid when you have the oil that's made, and it's too late very often. So that's one of the issue of the processing of the overwinter sample. So the other things that we did, we realized in 2017, when there was also an issue with the snow canola, that they were becoming orangey as time passed, and that orange tint is a sign of oxidation. So we did a couple of accelerated oxidation study using 4 temperature, and from those temperature we kind of extrapolate the shelf life at 20 degrees Celsius. And so the shelf life is in year at 20 degrees Celsius. And what we saw actually that there was quite a bit of a difference between overwinter and fall sample. That means that the oxidation is starting much earlier and going much faster in the overwinter sample than in the fall samples. And the shelf life of the seed, it's much reduced when you have overwinter canola. So meaning that those seeds cannot be stored and have to be processed and move pretty fast. Actually, some of the sample, they were number 1, and they have about a shelf life about 6 months. But at the same time, you have some of the sample that were pretty good and have a shelf life about 4 years. So, but again, it's difficult to know until you do the analysis, the chemical analysis, to know exactly where those samples are. So the other things that we did, when you calculate the shelf life, you have the rate of the oxidation, and actually the rate of the oxidation was the same for both samples. So there was no difference. Once the oxidation started, it proceeded at the same speed, except that for the overwinter canola, the oxidation started much earlier than for the fall samples. And then the last things that we did, we kind of look at what was the parameter that was really affecting the shelf life. What was the parameter that was the main problem and the main driver for reducing the shelf life of the overwinter canola. And actually, we find that the free fatty acid was the main factor. So the higher the free fatty acid, then the lower the shelf life of the overwinter canola. So again, free fatty acid being a problem, because being a problem during processing, but also being a problem for seed storage and seed oxidation. So this is the website link to get all those information. The report on the overwinter canola and the harvest survey report are always on the website. So I encourage you to have a look. And this is all the people that I have to thank for helping to collect the sample, sending the sample, and thanks for the people at the Grain Commission for the analysis and the grading of the sample. And I want to thank you for your attention, and have a good day.